All right, so next up we have Stephen Chandler, Paul, known as Liud, is going to talk about ps2emu. Is that, or emu? How do you pronounce it?
Emu.
Emu, okay, perfect. All right, go ahead.
All right, so I'm going to be, like you said, talking about ps2emu. I'm also going to be talking about how ps2 devices work. There's some basic documentation on how they work, but a lot of it in this day and age is not really accurate. So what is PS2, of course? It's an old protocol for mice and keyboards, pretty much still used in laptops every day, and it doesn't provide much bandwidth, but it works. It's still used in the vast majority of laptops. Just about every laptop in here is actually probably using it for the touchpad. So why is it still, and it only allows for 2-finger multi-touch. So why is it still used? Mouse support in UEFI. PS2 doesn't need any special drivers for that. Since this comes up as generic mouse, designed when PS2 was the only option. Older versions of Windows didn't have the ability to support touchpads across any other protocol you'd use inside of a laptop. So they're kind of stuck with PS2. And older versions of Windows still need it. Because of course we still gotta support Windows 7 and all that stuff on a couple of laptops. So we still have to have touchpads that can support PS2. So there are a couple of alternatives. They're not very widely used yet, but they do exist. You've got I2C, which is used by a couple Chromebooks, a few Dell laptops use it. You've got RMI4 SM bus, like Benjamin mentioned before. Kind of supported, it's getting there, work in progress right now. They're not widely used, like I said before, but they support more than 2 fingers, more bandwidth, et cetera, et cetera. So this is where stuff kind of gets a bit confusing. So PS2 and the kernel. The thing about PS2 is normally touchpad communicates over the i8042 controller. It's an old controller used to communicate with mice and keyboards, and that's pretty much all it does. The thing is, though, PS2 can be run over more than just that. You run into situations like the T450S, where you have a track point that's actually connected through the touchpad, and then the touchpad actually forwards that along with itself over to the host. As you can see there in the diagram, the internet connection between the track point and the touchpad, they both go through the controller, and they get abstracted through a layer called serio. What serio basically is it's a thing that you would run PS2 through, or any other serial mice protocol. The advantage of it is you don't need to know what you're running it over. It could be an i8042 controller, it could be over another PS2 device, pretty much anything. It makes it a lot easier because certain drivers we actually use, like track points might be used on older laptops straight to the PS2 port, but on newer laptops it go through the touchpad. So we need to be able to support both of those without any difference to the driver. So the basic PS2 protocol for mice, it's pretty simple. Each packet's 11 bits. Payload is 8 bits. Packets are sent out in groups of 3 for normal 3-button mice, and groups of 4 for 5-button mice. And a couple of commands you can send: reset the mouse, resend, etc. And the basic packet looks like this. You've got X sign, Y sign, for positive, negative, overflow, middle, right, left, X delta and Y delta, how much the cursor's moved in both positions. So it's pretty much designed for the general mouse, ball mice, you move it left and right, and that's pretty much all it does.
Sorry, can I interrupt? Can you speak up a bit because we need a file with that guy now?
Oh, yeah, sure. So, did you hear that last part, or? All right. So it's pretty simple, but there's not much room for improvement, which is where stuff starts to cause issues. i8042 controllers are picky, if you try to send anything that doesn't look like actual PS2 information, some i8042 controllers will either drop it, or some get even more creative and actually rewrite it in place. Which means you can't stick extra information in it, you can't add extra commands, because you can't guarantee that any of it's actually going to get to the device on the other end, and vice versa. So, of course, that means with the default PS2 protocol, you can't do absolute positioning, pressure, and so forth. So, of course, this doesn't work because we need this kind of stuff on the modern computer. You know, everyone wants two-finger scrolling and that sort of stuff. And we had to, manufacturers had to work around that. So what they do is they've made their own protocols to actually run over PS2. They add more information in the PS2 packets, but they do it in such a way that it looks like a normal PS2 event to the i8042. And this results in some really funky looking packets. So right here, you can see you've got the X position on, half the X position on byte 2, not actually half, about 3 bytes, but same with the Y position. You've got W value, which I can't remember what that stands for. I think it's the type of packet that's getting sent. Right mouse button, left mouse button, and then you've got the position spread over the rest of the packets. It's designed in a confusing way because it's really the only way to get the to ensure that the packet can go to the device from the host driver. In case, you know, it gets overwritten and stuff, the only parts that are getting overwritten are the parts we don't care about, which you can see 1, 0 there, that sort of stuff. Some of the data is also redundant so that controllers or drivers are able to tell if the i8042 controller is doing something funky, so they can ask it to resend. This, of course, gets pretty confusing, especially because the protocols aren't consistent. This is only for the Synaptics touchpad. It basically differs for every touchpad, and you can't really rely on it being the same even across different models. We've run into a couple of touchpads where they will actually report data slightly differently depending on the model of laptop. Like a couple of Dells will report their track point positions in different spots in the packet for not really much of a discernible reason. So, of course, it's usually the secondary, or whoops, sorry, wrong side. So they don't use these extended protocols by default. They usually work without special drivers because, like I said before, you have to support UEFI and all that stuff. So usually what you have to do is you have to activate it with special command sequences. For Synaptics, it's basically you send a set sample rate command. Set sample rate has a argument with about 2 bytes. It's usually either 40 events per second, 80 events per second, etc. But what you do is you send 6 of those commands, and you split each 2 bytes of the actual command you're trying to send to the touchpad through those commands. So this has become a bit of an issue because for some touchpads, PS2 is actually a secondary protocol. A good example of this is most of the newer ThinkPads. Their touchpads work over PS2, but they actually in Windows use RMI4. This normally wouldn't be an issue, but they don't really get the same Q&A testing that the primary protocols do. For example, we had to deal with an issue where Lenovo touchpads were not reporting their resolution properly, which was actually causing software button emulation to completely break. Software button emulation meaning, you know, you've got a click pad with no physical buttons. And thing is, these kind of quirks are really common. We've dealt with a lot of different cases of just touchpads not acting like they're supposed to, various firmware bugs, all of which are exemplified by the fact that there's not much QA testing on the legacy mode. So quirks in both the protocol and the touchpad. So this is where ps2emu comes in. This was something I made at Red Hat. It was my intern project. It allows us to record PS/2 devices from the PS2 layer, which means we basically have the lowest level possible recording you could get with these things. They can be replayed on other machines, so if someone's having a touchpad issue with their HP laptop, they can just record it, send it to us, and we can replay it. And if there's any bugs in the kernel, we can actually reproduce them locally, something we weren't able to do before. Before, what we would have to do is get a whole demessage, look at all the PS2 data coming through, and try to decipher the packets to see where we were processing them incorrectly. So it's helped fix a couple of bugs in touchpad drivers already. Like I mentioned before, we had an issue with a Dell with the track point on one of the Dell laptops sending data differently. We ended up fixing that, using that. Ended up finding a couple of touchpads that just don't send data properly. Something we might not have been able to pick up on without actually being able to replay it locally. So the ps2emu package comes with two basic commands. Records the PS2 devices, and replay, which just replays the devices. There's also one additional kernel module that's needed, which is userio. Basically, it allows you to create a virtual serial port. And what that means is we go back to what I mentioned before with the serio protocol. It basically makes it so that we put userio in the place of where the i8042 controller would be. And because the protocol is transparent for all the drivers, we can just forward whatever we got from the i8042 serio driver over through userio. So in this case, we would take out the serio driver there for replaying and just replace it with the userio kernel module, which ps2emu would then talk to. In order to get this recording, like I said before, we just listen to everything that's on the serio that comes from the serio on the i8042 driver, and do some cutting and chopping to filter out all the data that's not for devices that we care about, like the keyboard. And of course, that means we also get all the devices that go through pass-through. We basically get the full protocol. Something we can't really pick up with evdev or that sort of thing. So file format's pretty simple. Just shows all the data that came back and forth from the host and the device, sent, received, that sort of thing. So probably better if I just give a demonstration. So I've got a recording set up here. So as you can see, it actually starts communicating. Oh, whoops, sorry, not in cloned mode. Whoops. All right, there we go. Okay. So as you can see, it actually comes up to the kernel as a fully functional device. It looks like you just booted up your computer and it detected the touchpad. Did the full query, min-max coordinates, touchpad model, basically everything like you connected it. And as you can see, everything gets replayed exactly like it was recorded. This is just me moving around a couple of windows and that sort of thing. So the advantage of this is we don't need access to physical hardware as much as we did before. There's still a couple of instances where we need it, but because we can just ask a user for a recording now, we don't have to worry about all these different models not being able to fix issues in them because we don't have the physical device in front of us. When usually actually having the data coming from the physical device that has the problem is the only way to fix it, because of all the quirks I mentioned before between different laptops. You can't really take even if it's a similar touchpad from another model in the same series, you can't actually take that touchpad and get the same results most of the time. So let me just switch this back. Here we go. So there are a couple of limitations to it, of course, because the recording is just recording what comes back and forth from the touchpad. It doesn't actually emulate a touchpad in the sense that if there's any differences in the communication between the driver and the ps2emu, then what will happen is ps2emu won't know how to respond. We can't really, there's no reliable way right now to guess what a response would be to a command we haven't received. So pretty much what happens from there is just get errors and the touchpad doesn't initialize correctly. This also means that recordings can't work between kernel versions because usually between kernel versions, the interaction with the touchpad changes. You know, you query a couple of things that you might not have queried before. And as a result, unfortunately, that means that if you're replaying any sort of recording, you have to be doing it from the same version. Otherwise, it's probably not going to work. So there was another thing that we looked at doing with this, which was regression tests. Because we can now virtually replay a touchpad, wouldn't it be really nice if we could actually create regression tests with that to be able to see if we could stop, you know, breaking things on other devices due to all those weird quirks, all the things you know. Because it's such an easy to mess up thing with all the differences in the protocols between various touchpads, it would be really nice to be able to actually just test them without having to have every physical device in front of you. So I did try a couple of things. Whoops. So mapping touchpad registers, for example. Not all of the touchpads expose registers. So what mapping touchpad registers would have been is basically on a lot of touchpads you will have multiple registers that you can query for a value. One register might correspond to, if I give a good example here, like palm detection. You know, you might have a touchpad that does palm detection and you might want to toggle that on or off. You do that by querying that register over the protocol. The problem with this is you can't do it on all touchpads. Some touchpads actually don't have any concept of this, and just forward commands, like for Synaptics, that's the case. You don't actually have any registers that you work with. You just send the command that says, hey, change the resolution here, that sort of thing. We also looked into emulating a touchpad. This, of course, is really complex. It's very error prone. We run into the issue of we can't really know from the proprietary firmware on a touchpad, you know, everything it's going to be doing. The vendors might be able to do that, you know, but unfortunately it would be way too error prone, and we'd need one device or one recording for each touchpad because we'd have to emulate each touchpad separately. I'm not even sure if there is a way to be able to get all the information that we'd need to be able to do that sort of emulation, and then even if there was, it's just too error prone and too time consuming to actually make it worth the effort. So that's pretty much it.
Anyone have any questions?
Can you explain a little more exactly what happens when you're replaying a trace? Like, for example, let's say the trace has the user clicking the mouse at a certain spot on the screen. If you have like an icon on your screen in the same spot, will it get clicked? Like, what? Like, I guess how do you debug using the traces? Like, are you looking for, you know, you're looking for the maybe the trace should be scrolling a window, but it's not. Like what exactly does the trace do when you replay it, and how do you sort of use that to figure out what's wrong?
So the best way for me to explain this is actually to show it a little bit. Hold on one second. All right. So Usually, the easiest way to do that is, since a recording is only what we got and sent to the device, the only events we have are what the user recorded. So what we've done in the past is we say to a user, hey, make a few circles with the cursor, click a couple times, and what we'll have them do is we'll have them wait a certain period between each of those events. That lets us easily be able to actually differentiate what event is which. So for example, so that's of course just all the data going in and out of the device. So it would be something like this, for example. We ask a user to click 3 times. And it doesn't really show up there, obviously, because of course we've got all of that data, most of which is just pressure information. But usually what you can do, and let's see if we can go up a little while. You can usually get something like evdev and just look at the events when they happen and basically narrow down the time that they happen to the data in the log. And then what you usually do from there is, once you figure out where the actual click event is happening, you'd be taking it and copy and pasting it. And now that you have the click event separated from everything else, you basically just replay that event, look at the behavior from the kernel, change things here and there, and figure out from there what the kernel is doing wrong, processing that data that's causing the issue that the user is seeing.
So it's really more like the traces don't really move your mouse cursor on your screen. It's just more of pushing data through the kernel and then seeing what it does.
Mm-hmm.
Okay. Thanks. Any other questions? Once. Okay. Thank you very much.